Hello, welcome to another episode in the RPG and Go tutorial series. Today we're going to be adding buildings and other objects into our game. Now the reason this is getting a dedicated episode, even though we've already covered map loading, is because buildings and objects like that come in different shapes and sizes, and we need a robust system that can add in these large objects that are not all 16 by 16 as our normal tiles are, and for that we need to redesign how our tile map loads and add functionality for custom tile sets. And so that's a lot of information. Let's go ahead and break it down. So far, all the tiles we've been working with have been strictly 16 by 16, whether it be the grass or the paths or the players or the player or the enemies, they are all 16 by 16. When it comes to buildings and other objects like it, that is not always the case. For example, this tileset house.png, which is found in the asset pack in the description, has buildings that are 4x3 tiles, that are 3x3 tiles, that are like over here we have some that are 2x2 tiles, and so whenever we are drawing stuff, we have to actually take into account these different size things. We could take the easy way out and just render this as 12 different images, but this will give us issues in the future whenever we want to Y-sort things so that the player can walk behind the building and in front of the building and have it all be drawn in the correct order. And so to mitigate this before that becomes a huge issue for us, a huge architectural issue for us, we should instead add some more functionality to our system to be able to handle things like buildings and statues and the like. So how do we handle these different size things? Well, luckily, Tiled gives us some really neat functionality for this. Tiled allows us to create a tile set out of multiple different sized images. And so what I've done here is I've basically cropped out 3 of these buildings. I have building 1, building 2, and building 3. Then inside of my images folder, I have a new subfolder called buildings. And inside of there, I have these 3 buildings in here. So now it's up to us to create this tile set from this data. So inside of Tiled, let's go ahead and create a new tile set here. And I'm going to call mine buildings. And instead of making it based on a tile set image, let's go ahead and make it a collection of images. Click Save As. And now inside of our tilesets folder, I'll save it as a buildings.json. I'm saving it as JSON now instead of the .tsx, which is just an XML file, because JSON is easier to parse. And now we actually do need data from this tile set in our game. So go ahead and click save and you should be greeted with this empty tile set page. You'll also notice that I re-exported the tile set floor as a JSON file format, and it's very easy to do that. Just, open it up. So click edit tile set, file, save as, go to the tile sets folder, and then save it as a JSON file, and then delete the .tsx version, and it should be all good to go. Shouldn't give you any issues. Now that we have this empty tile set for our buildings.json, we can click the plus button here, and I'm going to navigate to the buildings folder, select all of my buildings, and click open. Now if we click on any of them, you'll see that it has created a tile set out of our images. So I can just scroll through here and we have some metadata on the side giving us the ID and the rect, which is very, very important. And you can see that the rect is a different size for this one than this one. So we have basically achieved different size tiles in the same tile set. Make sure you save this and then go over to the spawn.json, and let's go ahead and add a new layer for this stuff. So I'm going to make a new layer and I'm going to call this layer my objects. Now instead of objects, I'm going to go to my buildings tile set here, and I'm just going to place some buildings down where I see fit. Now let's go ahead and make sure to save this, and now we can go into our code and explore what we just did. Inside of the buildings.json file, you can see that this is the data that Tiled is reading to decipher what a tile set is. And it's a little bit different for this than our tile set floor. If we go to our tile set floor, there's a lot less stuff because it's a regular tile set that is just one image. So if we go back to our buildings.json, you'll see that we have an array of tiles. Each of them have an ID like normal, but they also have additional data like the image, which is the path to the image height, and the image width, which are very important to us because buildings are different widths and heights, as we've mentioned. And so yeah, now what we need to do is basically have a way to grab this data out of this tile set and use it inside of our project. So as of right now, we're just kind of assuming that all of our tiles are 16 by 16, but we should make that different. We should actually figure out how to get this working for all of our layers. And for this, we're going to need to first add some extra data to our tile map. So if we go to spawn.json, we'll look and we'll see that we have layers layers here, and each layer should have a name attribute. This is important for identifying, which layer we are actually drawing. Additionally, we're also going to need to look at our array of tilesets, which is just the different tilesets that we have inside of our game. And the reason this is important is because it tells us which ones to load into the game, and it also tells us what the offset is for each of these. Basically, this offset is to ensure that our tilesets do not intersect. If all of our tilesets started with 0, we might have some conflicts when we have a layer that uses multiple different sprite sheets. So we have this little offset here. So whenever we're using our buildings tiles, we need to apply this first GID, which is basically just our first tile ID. It's a lot, but So let's go into tilemap and let's add this functionality. So let's add the easy things in. Let's add the name first. So the name is just a string. So we'll add that to our tilemap layer JSON, and we'll add the tags here. So JSON colon, and then it's just name for each of these layers. That's the easy part. Inside of our tilemap JSON, we also need a slice of tile sets. So it's going to be a slice of tile sets, and we haven't actually made our tile sets yet. So I'm going to declare this here, but I haven't actually made it yet. Let's go ahead and create a new file for this. So I'm going to add a new file to our root directory. I'm going to say tileset.go here and add our package main to our file. And now let's go ahead and think about what we need to add to our tile set. So we have a bit of a dilemma. Our tile sets come in two forms. We have the one that's composed of multiple images like this, and we have the one that's composed of just a singular image with some additional metadata. We need a common interface to interact with our tile sets. So basically we give it an ID and it gives us back an image. That should, scream out to you if you are getting used to Golang now. It should scream out to you interface, interface, interface. So why don't we go ahead and do that? Let's go ahead and make a generic tileset interface. So I'm going to make a type tileset interface. And what does this tileset interface need to be able to do? Well, what we need to do is we need to be able to get an image when we are given an ID. So we need to be able to do .image here, and this needs to be able to return an EBA10 image. And honestly speaking, that is all that we really need for our tileset interface. Now let's go ahead and implement this in two different ways. First, the super simplest way, which is just the one for 16 by 16 tiles like we've been using before. So I will say type, and this will be the, I guess uniform tileset, and this will be a struct here, and this will just contain, a field for the singular image that it has. So image lowercase for privatization, and then it's going to be an EBA10 image here. And let's go ahead and actually implement this. I'm going to actually implement the interface. So I'm going to say function, and then I'm going to make it a method by saying uniform tileset, and then I'm going to say image. This is going to take in an ID int, and then this is going to return an EBA10.image, right? So what we now need to do is do what we did before. So if you remember, inside of our main.go code here, we had to basically do this by taking the ID and grabbing the source X and source Y from this code. So we can actually just copy that over and paste that here. But the difference is that our tileset actually does need to keep track of that GID. Remember, in the spawn JSON, there's an offset provided to each tileset. So the first tile for us is going to be 1, and the second tileset is going to be 579. What we need to do, we need to essentially subtract this GID from this ID and grab the actual ID from it. So inside of our tileset, I'm going to also store a GID, which is just going to be an int, and then I'm going to say that the ID minus equals our GID here. That will turn it into the actual ID that we need relative to our tileset. Now what we can do is we can actually do our subimage. So we can say return u.image.subimage, and then for the image's rectangle, we can say image.rect here, and then for the 4 values, we need source X and source Y, and then source X plus 16, and then source Y plus 16. And then we need to type assert this to an EBA10 image like this, and that should be all good to go. This should return the proper subimage. Remember, we're adding 16 like this directly because this uniform tileset is the one that handles ones that are strictly 16 by 16. Let's go ahead and actually handle the difficult one, which is the tileset for dynamically sized tiles. So let's create our new type. We'll say type. We'll call this our dyn tileset for basically saying dynamic tileset. This will contain our images. So we'll say images, and this will be a slice of EBA10 image pointers here. So multiple images, and then it will also contain our GID here. And remember that the image has a bounds, so it automatically contains our size here, this bounds. So that's all done for us, and we can now do a similar approach. So let's go ahead and create that function again. So func, and I'll say dyn tileset here, and then I will say image id int like this, and this returns an ebiten.image. And now what we need to do is we basically just need to again say id minus equals d.gid, and then we can actually do something pretty cool here. Since the images are just like standalone images, we can return d.images at this ID, and that's it. So now we have these tileset things kind of implemented on their own. We need a way to sort of detect when to use which tileset. And we could hard code this, or we could make it dynamic. It's kind of up to you, but let's go ahead and first shell out this function. So we'll say function new tileset here, and this is going to take in a path, and it's going to return our tileset object. The reason that I'm not using an asterisk here is because interfaces in Go are all pointers. So detecting whether to use a uniform tileset or a dynamic tileset can be a little bit difficult. So for now, and this will be changed in the future, for now we're just going to check if it is this path. And if it is this path, then we're going to, pick X version tileset. Otherwise, we'll pick another one. So loading the tileset dynamically could be a little bit difficult because we have to do some checks before we actually parse the whole thing to make sure that everything works. And unfortunately, tiled does not give us any information like a type, for example. So it says type is just a tileset, but it says that for both of these. So it doesn't really work that way. And so the only real way to do it without getting too crazy is just to explicitly check for right now. So what we'll just say is in the beginning, we'll just say if strings.contains, and then we'll pass in that string. And then we'll say if it contains buildings, then we want to make it a dynamic one. So we'll say like return dynamic tileset. Otherwise, we will return a uniform tileset here. Okay, so now that we have this logic created for our new tileset function, we need to actually load in the dynamic tileset and load in the uniform tileset, which means that first we need to actually create structs to deserialize this JSON data and then convert them into these structs here with this images array for our dynamic tileset and the single image for our uniform tileset. So let's go ahead and just put them, I'm going to put them like right above each other. So I'm going to say type, and I'm going to say uniform tileset JSON here. And what do we need for this? We just simply need the path, which is a string, and we need the GID, which is an int here. Now the GID is actually going to be passed into our new tileset function. So let's go ahead and add that here. So I'll say GID is now an int. And again, we're going to go up to our tileset here, and I'm going to create a JSON version of our struct. So I'm going to say type dyn tileset JSON here is going to be a struct. And this one's actually going to be a little bit more involved. We're going to have a list of tiles, which is going to be of type a tile JSON object, which we haven't created yet. But we're going to say type tile JSON, and this tile JSON struct is going to have an ID of an int, a path of a string, and then a width of an int and a height of an int. And then we can say that this is now a slice of tile JSON objects. Now let's go ahead and add our JSON tags here. So this is going to be backticks JSON : tiles, and then all of these are going to be JSON : I think this one was ID, and this one was image. This one was image width with no spaces, and then this was JSON image height, and this should be a capital P. Whoopsies. And then up here for our uniform tileset JSON, let's go ahead and do backticks JSON : I think this was image. And then for GID, this is going to be given to us. So yeah, we also have to go back to our dyn image JSON and change that. But let's go ahead and make these. And let's also make these public for easier use. So those are now public. And we can remove that GID from the uniform tileset JSON because that doesn't actually need to be in there. I don't know why I put it in there. Just for a refresher, the data that we're referencing here with these JSON objects is inside of here. We want to grab this image, which is our path to our image, and inside of our buildings.json, which is our dynamic tile set, we want to grab this tile array, and then inside of that we need to make an array of tiles, which is an ID, a path, a height, and a width. So we are kind of breezing by this a little bit, but that's because it's a lot of information that I have to kind of cram into this one video. video. So now that we have our dyne tileset JSON and our uniform tileset JSON, let's just go ahead and add that logic directly into this new tileset here to make things a little bit easier. So no matter what kind of file it is, we want to read the contents of it. So I'm going to put that here before the if statement. So I'm going to say contents error : equals os.read file, and this is going to take in that path. And then we'll say if error does not equal nil, then we want to return nil and error. Now, right now we aren't actually returning a possible error, so I'm going to edit our return statement to accept a possible error here. And then after this error check here, we can then create our object. So if it's a building one, we want to create a dynamic JSON object. So I'm going to say var dyne tileset JSON of type dyne tileset JSON, and then I'm going to say error equals JSON dot on Marshall. I'm going to pass in that contents, and then I'm going to pass in a reference to our dyne tileset JSON here. So that should properly unmarshal things. If it fails though, so if error does not equal nil, we will return nil and the error here. Now we should have a valid tileset JSON object for our dynamic tileset. So what we can do is we can create a new dynamic tileset, the actual real one. So we'll say dyne tileset here, and I'll say that : equals a new dyne tileset object here. And then for the GID, so I'll say .gid here, I'm going to set this to the GID that we pass in. And then for the dyne tileset.images, we're going to need to do some more processing. And so what we can do for that is we can say first the dyne tileset.images is going to equal make a new slice of images of size 0, and then what we can do is we can loop over these tile JSON objects that we have here. So if we go to definition, this is what we basically have. We have a list of these inside of tiles, and we need to basically load in the images from all of these. So now what we can say for underscore tile JSON : equals range, and then we'll say dyne tileset JSON dot tiles. And then we want to say image underscore error : equals epiten util dot new image from file. And then we want to pass in this tile JSON dot path here, and then we'll just basically say if error does not equal nil, then we can say dyne tileset dot images equals append, and we want to append that new image to it. That's a lot of stuff, but that should be good for our entire dyne tileset there. Now for the regular one, it should be a little bit easier, and it should be very similar code. So first we need to again deserialize things. So let's go ahead and add that in here. And then finally, we want to actually process the data, which is a lot simpler here. So we can say uniform tileset, which is our actual front-facing one. And then we'll say : equals a new uniform tileset object here. And now we need a couple fields. We need the image. So uniform tileset dot image is going to be equal to our uniform tileset JSON dot path here. So now what we need to do is we need to load in that image again. So the exact same thing we did with here. So let's go ahead and just copy it and paste it here, and then change tile JSON dot path to uniform tileset JSON dot path, right? And then what we can do is after that all works out and the error is hopefully not nil, then we can say uniform tileset dot image equals our image that we just loaded in. And then for uniform tileset .gid, we're going to set it equal to our GID. Finally, we'll return uniform tileset and nil here. And we also have to make sure that at the end of this one, we return our dyne tileset and nil. That's a very long function. That's a very, very involved function, and there will be plenty of comments in the repository to hopefully help explain that, and I will probably go over this a little bit later in the video as well. Back inside of our tilemap.go, we need to actually be able to get these tile sets. So I'm going to create a new field inside of our tilemap JSON, and this is going to be a map of a string to an any. And the reason I'm doing this is because I'm a little too lazy to create another data structure for just these tile sets like descriptors here. Basically, this right here is a map to an any, because it's an any because it's either a number or a string, so it's an any type, which can kind of be asserted to either a number or a string or other stuff like that. So let's go back to our tilemap.go. Let's add that tag. So this is our tile sets here. So we'll say JSON : tile sets. And I actually messed up the type definition a bit. This should be the value here. So we would actually paste it here. And then the key would be string, and then the value would be a map with a string to an any here. So this is the actual definition. It's just a double nested map with the last values being either like a string or a number or anything like that. What you'll see in this tutorial series is that a lot of game development is serializing and reading data. A lot of it is that. So we do have to get very, very comfortable with using things like JSON, which is why it's so popular in the game industry. So let's go ahead, let's just add a helper method to our tilemap JSON. So I'll say func t tilemap JSON here. And this is just going to say gen tilesets. And this is going to return a two values. So either a slice of tilesets or an error here. And now what we can do is we can just loop over this. So we'll say for underscore tileset data equals range, and then we'll say t.tilesets. And remember, this is our map to a string to a map to a string to an any. And now let's go ahead and basically generate our tilesets from this. So we will say tileset equals a new tileset here. And remember that we need to provide the path. So for this, we need the path data, which is inside of spawn.json. So the path data is here. It's called the source one. So what we would do is we would grab the source, but we have to be careful because this path is relative to wherever our map is. So we have to actually add on the assets, maps, and then the assets and then maps to it so that it properly maps it correctly. So let's go ahead and define our tileset path, and it's going to be equal to path.join. And we're just going to hard code it for now. So we're going to say look into assets, look into maps, and then we want to join this with our tileset data, and then we want to index into this and say our source. And I just realized an error. This isn't a map to a string to an any. It should just be a slice, because the spawn.json is not actually a map into a map. It's actually an array of maps. So that was my mistake. It should just be a slice of maps. And we need to make sure that this is a string. So we need to assert it to a string. We are just going to be assuming that this turns into a string. And we're just going to make sure that it always has this source field. If this didn't have a source field, it would return a runtime error trying to assert it to a string. Now, inside of our new tileset here, let's pass in this tileset path. And then finally, we will pass in the tileset data at, and then we need that one thing here. So we need to go back to our spawn.json. Look what it's called. It is called the first GID. So we're going to go back to our tilemap.go here, and we're going to say first GID, and then type assert this to an integer. Make sure that that all works out. Now this is freaking out because this needs to be first a declaration, and also needs to be able to capture the error. And then we can basically just say, we can say if error does not equal nil, then we want to return nil and an error. Otherwise, we want to append this to some list. So let's go ahead and go to the beginning of our function, and we'll say tilesets equals make, and we want to make a new array of tileset interfaces of size 0. And then if we pass the error, we want to say tilesets equals append our tileset at the end here, like that. Finally, at the end, we can return our tilesets with nil, and that should be able to give us all of our different tilesets in an array. What can we do with this? Let's go ahead and go into our main function, and let's start using it. So I'm going to go into here, and I'm going to say our tile sets, and this is going to be an array of our tile sets. So I'll say array of tile set here, tile set interfaces, and then I'll go down to where we are creating our game. After we generate our tilemap JSON, I'm going to say tile sets error equals tilemap JSON dot gen tile sets here, and then we'll just say, if error does not equal nil again, and then we want to fatally log that error out. Now we can actually inject this into here. So after our tilemap JSON in our game constructor, we'll say tilesets and map it to that tileset struct there. It's a lot going on in this tutorial. It's a lot of moving parts, but we're getting into the deep end of game development here. We're getting into the really nitty-gritty stuff. So keep with me. We are getting there. Now, whenever we're actually drawing our tiles, we no longer need to do this sort of source calculation here. So what we can say is we can just say image equals, And then we're just going to use the index of the layer as the index into our tileset, because as of right now, they are pretty uniform, but later on we'll have a system to sort of map them together. So I will change this underscore to actually capture the layer index here. And then I'll say here, image equals g.tilesets at the layer index. And then I will say dot image. And then for the image, we want to pass in the raw ID, because remember, we handle the GID automatically. Finally, instead of using all this stuff, I'm just going to comment this out here, but I am going to use this stuff here. So I will grab this stuff and then I will paste it here, screen.draw image, and then I will pass in the image and the options. So this simplifies our draw thing by a bit by not having to calculate the source for all of them. It's kind of just already calculated for us. So let's go into here and let's do a little go run dot. So we're getting a panic interface conversion. Interface is float64, not int. This is happening at tilemap-go at 28. So let's go ahead and go to our tilemap.go and let's go to line 28, which is tileset error equals a new tileset here, and we're trying to parse it into an integer, but I guess it's turning it into a float64, which is okay. We can do that. So we can just basically turn this into a float64 here, which will give us an error here, but we can just wrap it inside of an integer. This is just one of the quirks of turning it into an any type, and so that should be okay, because if we actually look at the data inside of our spawn.json, the number should just be an int, but I guess Go is just being safe and turning them all into floats, which is, you know, it's whatever. Now we can do go run dot. Now there is one more error. If we do go run dot, you'll see that we have this error that the system cannot find the file specified, and it's for // images. And the reason is because if we go to our tilesets, all of the images are relative to the project again. So again, we have this relative path issue. So what we have to do is whenever we are loading in our paths, we have to convert the path to being actually relative to our root. So it adds a little bit more complexity, but not too bad here. So instead of just taking that path directly, so in order to convert this path into a path relative to the root rather than relative to the map, we have to do a little bit of path magic here. So the first thing I'm going to do is I'm going to actually grab the tile.json path here, and I'm going to say that's equal to the tile.json.path. The next thing I'm going to do is I'm going to clean it. So just clean up the path itself. So I'm going to say tile.json path equals, and then I'm going to do file path .clean, and this will take in the tile.json path. The next thing I'm going to do is I'm going to do tile.json path here. I'm going to say tile.json path equals, and then we're going to do strings.replace all, and I'm going to replace for the tile.json path all instances of backslash with a / here, and this will help us with these weird // things that we get inside of this JSON, which is a little bit hard to work with. The next thing we're going to do is we're going to say tile.json path equals, and then we want to do strings.trim prefix, and we're going to pass in that tile.json path as the target of what we want to trim, and we want to trim the // Finally, we want to trim the actual slash here, so we're going to do that again, and then we can actually append the assets to it, so we can say tile.json path equals file path .join here, and we want to join it with assets and pass in that tile.json path. So this is more like path heavy stuff, so that's why I'm kind of going quickly, because it's not super relevant to game development. It's just more like handling different types of paths and getting things from one relative space to another. So now we can paste that here and replace this with uniform tileset JSON.path, and then use this tile.json path inside of here. So tile.json path here, and there we go. Okay, so there was actually one mistake. This should not just be slash for the second one. It should be .. again. So we should be doing this twice here instead of just once, so as you can see with this here. So that should all be good. There is one more thing we have to do, and that's something I forgot to do in the beginning, was that inside of the draw method here, what we need to do is we need to early return if the ID is 0. So let's go ahead and do that. So we'll say if ID equals 0, then just continue, which basically means skip this loop and go on to the next. Now if we do go run dot, Okay, so we're making some serious progress here. As you can see, we finally have some results for our work. We have our building showing, but some data is pretty darn messed up. And now let's go ahead and look at what that is looking like. So it looks like instead of getting the grass, we're getting the one to the left of it. So we are actually getting a weird result, and that's because I kind of just hard-coded this here. And for now, we're going to keep that 22, which is just the width of our tile set. We're going to edit that in a future video. I'm just going to get rid of this -1, which was temporary in the first place, and we're going to replace that with the actual just regular ID. That was because in the beginning, we weren't taking into account the GID. Now that we are, that's handled for us. We now see that we have some buildings loaded. All of that work. We finally have some buildings that are on the screen. Now this is a huge, insanely long tutorial. Let's go ahead and make it so that the fruits of our labor are a little more worth it. So I'm gonna add a couple more things into there. Let's go to here and let's add in like a statue. I'm gonna add in this knight statue here, copy it, make a new entry. I'm gonna just paste it in here, and then I'm going to save this as like knight.png, and then I'm gonna save it inside my buildings directory. Inside of here, I will add it into my tile set, save that, go into spawn.json, go into my buildings, click on that, go to my objects, and I'm going to add one in like right here. Why not? Let's go ahead and save it, and let's see if this automatically picks up on this object. So let's run it. And there you go, we have it. Now there is one last thing. I know this has been going on for a really long time. This is a long video, but there's one thing. You'll notice that these tiles are a little bit off. They're like in a weird position. And the reason is because the position that they are given is relative to their bottom left position on tiled, and we need to turn this into the top left position for drawing. And so the way we can do this, we can go into we can go into our draw code here, and we can go into main.go. At the end here, before we actually draw it, after we do our actual translation for the position here, what we'll do is we'll say ops.geom.translate. For the X, we don't want anything because it starts at the bottom left. We just want to make it to the top left, so we'll say 0.0. But then for the top, we want to translate it in the negative of the image.bounds.dy, and then we want to re-add one tile size back to it. Now if we run it, we now see that everything is in where it should be. We now have our buildings here, they're cut off because they're at the top of the map, and we have our knight here, and we have this building here. So everything is loaded as expected. That just took a very long time. I'm not sure how long it will actually be when I'm actually finished, but the recording is currently sitting at like an hour and 10 minutes. For this episode, I highly recommend checking out the Github repository. There will be more comments on it, and you can basically go a little bit slower than I did to hopefully digest the information a bit more. But for now, let's go ahead and just quickly run a little demo of what did we actually accomplish here so that you can get a better picture of what is happening. So first, we added some new data to tilemap.json in order to load in our tile sets. The first thing we did was we added our name, which we haven't used yet, but we will use in the future. The second thing we did is we added the list of tile sets, which is a slice of maps to any types, which is this area here, these tile sets here. Then we have this tile set, tileset.go file here, which has a tileset interface, which is defined as simply something that when given an ID will give you back an image to draw. We then created two implementations of this. The uniform one, which is just for static 16 by 16 tiles. Now the part that's actually new and interesting is the dynamic one. The dynamic one is defined in JSON as a slice of tile JSON, which has four things that we care about, which is the ID, the path to the image, and the width and the height of this dynamic tile. From that, we can then use the actual front-facing one, which is the dynamic tile set, which is a slice of images, and these images are created from this data here from the path and the width and the height. And then we have the GID like before. And the image is as simple as indexing into this slice. So it's actually a little bit quicker than the other one if you really think about it. This huge function will be documented a lot more in post, but basically we take in a path, we detect whether it is a dynamic tile set or not with just a simple if statement for now. If it is, then we parse the JSON, then convert that JSON object into an object that we can actually use, and then we load in all the images beforehand and we export that object and return it. And then finally inside of our main.go, instead of doing all of the grabbing source inside of the Go file itself, we instead grab the image from the tileset at that layer index, because remember, all tilesets have an image function because they all implement the tileset interface. So this grabs the portion of the image we want to draw, and then we simply just draw that image. So overall, our draw method has become a lot simpler, and we can actually completely remove all of this code. And there you go. That's a basic gist of how this went. Hopefully this video isn't too long, and hopefully you enjoyed. Now maybe you can see why we needed a dedicated video to the buildings. But anyways, thank you very much for watching. If you enjoyed this video, make sure to like, subscribe, consider joining my Discord, where there are other fellow game developers to help you out with things, including myself, and it's a great community to come and chat with. Additionally, consider supporting my Patreon so I can continue making videos like this. Thank you very much for watching. Have a good day. See ya.